Well, good morning, everyone. I'll just ask if you want to grab a snack or a treat, please do so, but then you can come grab your seats. And to those of you that are joining us online, welcome. I hope you guys also have a snack or something that you guys can enjoy as we learn about these exciting projects. So my name is Katie House. I am the theme lead for the Novel Land and Wellsite Reclamation theme here within CRIN. So CRIN is the Clean Resource Innovation Network. And I'm really excited because today we get to talk about some projects that we funded through some of the funding we received from the Strategic Innovation Fund. And this will be the first of a couple different project cafes that'll highlight some of these projects over the next coming weeks. So this morning, our agenda, I'll just land acknowledgement we're going to start with. So here we're located in Calgary. If you look outside, it's an absolutely gorgeous day. So if you're online, I hope you guys can look outside as well and spend a little bit of time today just considering the land that we're on, wherever you guys are located. But right now we are located in, for the part of this, sorry, are my notes. So we want to acknowledge that the land we are on here today and that we work, that we play in, is land of those that came before us. So this is the land of the Blackfoot Confederacy. Sorry, as I flip my page. And so I want to acknowledge the land that the Siksika, the Kainai, the Piikani, the Treaty 7 tribes, which compose of the Tsuut'ina, the Stoney Nakoda Nations, and the Métis Nations, home of Métis Nation number 3. And we also want to acknowledge all the other people who make their home here in Southern Alberta. So in terms of our content here today, I'll have an agenda come up. So I'm here to welcome you. Outside of working with CRIN, I work at Canadian Natural Resources, and I work in our corporate liability team there. Today, we're going to have Glenn come up, and Glenn works with CRIN. He's going to share a little bit of the CRIN lessons learned. Then we're going to have Andrea Crook come up. She's going to speak a little bit about EcoSeis. And then we'll have Fred Wassmuth come up and he'll talk about some alternative cement products as well. At the end, we'll have an opportunity for Q&A. So if you're online, you guys can put in your Q&A online. We'll bring that up and ask the presenters who will come and sit up in front here. If you guys are in person, you guys can raise your hand. We'll bring a microphone around to you guys and you can ask your questions to them as well. And we'll try to hold questions for the end, but if you want to jot them down or if you want to put them in online, if you're on Zoom, you can add them in as we go. And then once we're done, we'll wrap up with some coffee. So the first speaker up is Glenn. So Glenn, I'll ask you to come on up here and I'll just introduce you a little bit. So Glenn is our Director of Operations here with CRIN. He's a senior business leader. And one of the things I love about Glenn is that he inspires change, but he also says better is always different. So I think that's a great quote to kind of be associated with because I think that's true. Glenn was with Husky as the Chief of Innovation in 2018 and built his expertise on the technical leadership and out-of-the-box thinking. Prior to that, he was appointed as Chief Geologist within the company and has also held the roles of Manager of Frontier Exploration as well. He began his career at the geosciences with Imperial in 1996. So through this time, you've had offices in Houston, Calgary, out east in St. John's, anywhere else?
That's close enough.
Close enough. And then I guess his spare time, you're on the board with Alberta Innovates and also a special advisor to the Clean Resource Innovation Network here. And you've received your BSc from U of C in geology, University of Regina in geology, and then a master's from Earth Sciences in the University of Ottawa. Awesome. So I told all the presenters that we're going to also do a little lightning round of questions just to kind of liven things up because that's just what I like to do. So I have given them these questions in advance. So Glenn, first question, favorite day of the week? Sunday. Love it. Place you want to travel to?
New Zealand again.
New Zealand. Awesome. Great spot. Favorite thing about Canada?
Friendliness.
Ooh, good question. If you could eat one thing straight for an entire week, what would that be?
Cheeseburgers.
Ooh. And then, I mean, the most telling question, the mall, Starbucks or Timmy's?
Oh, I go Timmy's.
A good Canadian right there. Awesome. Well, with that, I will turn it over to Glenn.
Fantastic. Thank you very much, Katie. And it's always a pleasure to see people in person. I know there's lots of you online as well, and that's fantastic. Welcome. Meeting some people again today that I've only really have ever met before on the Zoom screen or a Teams screen, where they're just disembodied head in a little box, right? So it's great to put bodies to faces. So welcome all of you who are here in person. And with that, figure out how the clicker actually works on this thing. Got it. All right, so CRIN. So CRIN is a pan-Canadian organization that has the vision of Canada as the global leader in clean hydrocarbons from source to end use. We are a volunteer-driven, not-for-profit. We don't compete with any other stakeholder groups. Instead, we work to collaborate and amplify the efforts of others. And CRIN membership is free. So any of you who are not CRIN members, there's no reason not to join. It's free, and it's open to individuals as well as corporate members. Within CRIN, we have, here we go, 7 theme areas that were selected based on the need to address technical gaps and identify and promote solutions to priority energy challenges. And they're listed on the slide here. And the technology gaps are addressed through multi-sector collaboration across the CRIN network. And today's focus is within the theme area that Katie leads for us on novel land and well site reclamation, so land-related projects. With regards to competitions, I'm not sure where to point this thing. Here we go. So CRIN was fortunate to receive $100 million in funding from the Government of Canada's Strategic Innovation Fund. $80 million of that funding has been utilized for 3 technology competitions focused on technology development and deployment. And the remaining $20 million is used for ecosystem support for projects and events that help reduce barriers and create what we call an industry pull. Highlighted in red on this is one of the 3 competitions is reducing environmental footprint, which is the focus of what we're talking about today. And that's particular competition was operated on behalf of CRIN by Emissions Reduction Alberta. There was over $50 million awarded over 16 projects. And it has now been about a year since we've announced the winners. And each of the funded projects is really a win. And it's been a win to advance the commercialization of innovative solutions. And one of the things that, we're really proud of is that, each of the winning projects is a collaborative partnership between oil and gas producers and innovators. So that in itself is a big win. It's that industry pull. And of course, there have been some challenges along the way. Logistics, process challenges for navigating, getting contracts. You think there's, in the neighborhood of 50 projects being funded. They all have to be contracted. Lots of good learnings come out of that. And also with the claims process with government, this is money coming from the federal government on a reimbursement model, and lots of learnings to come out of that. So again, one of the things we're proud of is that we have learned. And we've learned how to collaborate to identify solutions to some of these challenges. And, such as an example is we've introduced some changes recently to our claims process to get money into the hands of innovators sooner, because that was considered to be a bit of a pain point. And so I think we're also proud that, we've been working together to identify solutions, but we've also got the flexibility to modify processes and whatnot to, come up with solutions. So with that, I'd like to get into really talking about some specific winning projects. I'm going to hand it back over to Katie.
Awesome, thank you. So both of these projects are ones that I've kind of been following personally from afar for quite a while, and I was so excited to see them as winners of some of the funding that came out, because I think they're just both excellent projects, and I can't wait to see kind of the updates here today and to share that with all of you. But I'll ask Andrea to come up first. So Andrea Crook graduated from the University of Manitoba with a BSc in honors in geophysics. She's currently the CEO of OptiSeis, a company that you founded in 2011. Awesome. In addition to that, you've experience with Shell and Boyd Petrosearch as well. Yes. Awesome. So I'll let her talk about what OptiSeis and EcoSeis is. But just a little bit further about her, she also is an instructor with SEG and with the CSEG Doodle Train. Is that correct? And also received some technical achievement awards from the SEG. You've been a symposium nominee, and you're also on the board with CRIN too. So you're a very busy lady.
Yes, and I joined the CRIN board very recently, and it was well after our project was selected.
And we appreciate her perspective too, as someone who's going through this with us and pointing out just where's we can improve to within CRIN. So that's awesome. Okay, icebreaker questions for you. Same ones. Favorite day of the week?
Thursday, because it's the day that I come downtown and meet with people.
Oh, awesome. Where's the place you'd like to travel most?
Anywhere with water to swim in or interesting rocks. So the Canadian Shield ranks quite high.
Okay. Favorite thing about Canada?
The diversity of the people.
Awesome. If you could eat one thing straight for an entire week, what would this be?
Okay, this is a little different. I love roast turkey so much that we have roast turkey like 5 or 6 times a year. And then we eat turkey every day afterwards.
Awesome. And then Starbucks or Timmy's?
Neither, because I don't actually drink coffee. So when it comes to a coffee shop, it's whatever a client or a friend wants to go to.
Fair enough. I'm impressed you do all this without coffee. This is very impressive to me. Awesome. Okay, well, I'll let you take it away.
All right. So I'm Andrea with OptiSeis Solutions Limited. I'm just going to see. Okay, there we go. So CRIN asked us to go through kind of the problem that we're addressing, what some of the alternative solutions might be, our EcoSeis solutions, and our measure of success. So starting out, I'm going to go through the problem. My background is geophysics, and I specialize in seismic acquisition. And for those of you not familiar with seismic acquisition, basically we're taking pictures of the subsurface. So similar to an ultrasound, you have an energy source, which would be deployed along these red lines, and some sort of sensor that's going to record the sound wave reflections, and that would be deployed along these blue lines. In Alberta, if you fly over northern Alberta, you'll see lots of lines that are cut in the forest. Many of these are very old lines using practices that we no longer do, and that's part of our research on how these regrow. How you deploy these lines affects how deep you can see. So when we move into areas like the oil sands, we need very high density seismic to get a good picture. And this has been recognized in industry as a problem, particularly when we're working in sensitive habitats. So starting in 2017, COSIA began looking into this to figure out if there's technologies that can reduce that land footprint. So our technology partially addresses the COSIA land challenge, and we're looking for ways to get the high resolution image while reducing that land footprint. So I'm going to play a little video here, and this is a flyover of a seismic program. So you can see those intersecting lines, but you also see some very thick, wide lines where there was a pipeline. You might see some roads, some of those old 2D lines. And as we do exploration, like we come in, we explore seismic, then we have to drill like those squares or well pads. Then eventually you put a plant in. Sorry, I'm just going to go back here. So there is an increase in our human footprint in these areas, and that can have an impact on sensitive species. And also we need to use a lot of equipment to deploy the sensors. So there's GHG emissions associated with acquiring this data. So some of the potential solutions that have been proposed in industry are to miniaturize equipment. What you see here on the top are some of those cut lines in winter. And then the bottom picture is also a seismic program. You can see some lines where there's tracks in the snow, but this is using some of the more modern techniques like the low impact seismic to work within the habitat to reduce the impact. Another thing that lots of companies have looked at and is one of our areas of specialty is, can we change that pattern? So instead of having all the lines intersect, which can cause some fragmentation, can we use a different pattern of deploying those red sources and blue sensors and still get the same data quality? But if we start changing the patterns, then we're going to rely more on computer processing algorithms to put the data back together. So the top picture there shows the data before it goes through one of those processing algorithms, and you can see those gray spots where there's no data. And then the bottom picture shows how after you go through some of the more advanced computer algorithms, you can recreate some of the data. But we need to make sure we have the right distribution to recreate the data. So our project utilizes aspects of all of that. So the miniaturized equipment, alternative geometries, and processing advances. And the key focus is we want to take those technologies and reduce the land footprint. That's the #1 challenge. But if we also want to try to reduce the emissions associated with acquiring the data. Now, when we start applying those reductions, everything we do has to ensure that we still have good subsurface data quality, because if we're going to go cut trees or create emissions, we want to make sure there's a purpose. And if we get poorer data quality, then we've just wasted a lot of money and haven't gained any benefits. And when we go out into these remote areas, we need to make sure that the work is done safely, and we want it to be very efficient. There are patterns that you could use that reduce the footprint, but maybe they're not efficient to move through the field. Now, if we can do all of that and also reduce costs, then we have a winning solution. Reducing costs was not our main goal, but we found that as we increase efficiency of the operations, there is a potential cost reduction. And when you're cutting fewer trees, well, there's a reduction in the cost to cut the trees. So I'm not going to go through the technical results here, but I'll tell you a little bit about how we went through the project and what we considered the measures of success. So there's 3 steps to it. First of all, we need to validate our technology and the complementary technologies from the companies collaborating with us. We need to quantify the results. So it's not just about looking at the picture and does it look sort of similar? There needs to be numbers associated with that. And then a lot of what we're doing, we code into our software. So we can provide this solution as a consulting service, but there's only a limited number of us at the company. So if we can also get some software to provide this solution to others so they can implement it, then it will become much more widespread and more people will be able to adopt it. Some of the metrics of success when we first put together the proposal back in 2021 were reductions while remaining data quality in linear disturbance. So we were aiming for at least 35% on the project target. We hit 47 with the data that we just acquired. And some data sets are showing above 55% reduction in linear disturbance. Aerial disturbance, we were aiming for 20. We're up in the 35 to 40% on our current project. Emissions, we're aiming for 15 on the project. We're still calculating those, but the desktop studies showed a 55% reduction. So we're going into that in a lot of detail because we think we're going to far exceed that. And cost, this was an experiment, so we weren't expecting to go out there and have cost reductions immediately, but we have gone through calculations now that show, easily 5 to 10%, should be at least 15%. If we really are optimizing it, could be up to 25% reduction in cost. So as we go through the technology validation, we're looking at seismic acquisition, the processing where we're putting the data back together and creating some data, and then quantitative interpretation. So we want to make sure we're validating all the way through to the end use. And that's going to be in reservoir characterization and rock properties. When we're quantifying, Those are our quantification metrics over there, looking at the land footprint, the GHG and methane emissions, because when you're cutting trees or you're moving in areas where you may be compressing the soil, there are studies that show that decomposition and soil compression can release methane, and then cost comparisons. And then in the software, we're incorporating all of our learnings into the software, and we are geophysicists, but we also have environmental companies working with us, as well as statistical analyses. So we're getting a lot of data incorporated in, and then we're building some predictive algorithms. Now, there's other benefits to the project as well. I'm currently preparing a year-end report for Alberta Innovates, and they asked us to go through and list all the companies participating. So we have our 5 main companies, but there are actually 34 companies when I go through the full list of everybody involved in the project. That's a lot of collaboration with many of them are other small or medium enterprises. We had targets to hire more people. We were a company of 3 back in 2020, and we now have 10. Job retention and creation. I like seismic. We have to do better if we're going to acquire more of it. So my long-term goal is that we can all keep on working in industry, because seismic is not just oil and gas. If any of you were at the Williston Basin conference this week, it's for lithium, helium, geothermal, and carbon capture, utilization, and storage. And then we're very big on publishing, which I'll talk about a bit. So project timeline. This kind of shows the history of EcoSeis. The EcoSeis itself was first conceptualized in 2020 when it was submitted to the Imperial Clean Tech Challenge. But the ideas have been in the works for 10 years already. We were a consulting company. We were going to present this at the Imperial Challenge in Seattle in March of 2020, right when the first outbreak in North America happened in Seattle. So plans changed. We knew about Alberta Innovates and that they helped fund companies that were doing research. And we thought, with a lot of the consulting work being put on hold, maybe we have time to actually finally do research. So we started putting together a group of companies. We went to COSIA and we had 5 of the oil sands operators join us. Alberta Innovates put in money, as did NRC IRAP and ourselves. We raised $600,000 to do the initial desktop studies. And the technology also in 2021 placed second in the COSIA Challenge. We are collaborating with the first place winner, which is one of the companies that has a miniaturized source. The successes of phase 1 led us to apply to CRIN. So the first pilot, we needed 6.4 million because seismic is expensive. And that's what made the CRIN technology competition very attractive, because they were offering 50% for field-ready projects. So our project was accepted. That's why I'm here. Our other collaborators are Canadian Natural, Conoco, Cenovus, Imperial, Suncor, ourselves, Alberta Innovates, IRAP, and after the project started, PTAC also joined us, and they are sponsoring our environmental work. So we're very grateful to all of our sponsors for this. So moving on, this just shows a little bit about the technologies and how I was explaining this. You know, we are looking at miniaturized equipment, alternative sampling theorems with the geometries. We're taking into account sensitive habitats. So all of this together is what makes up the EcoSeis project. And like I mentioned, when we start validating, we need to validate all the way through to the end results. So for the geophysicists, we're looking at seismic acquisition, processing, interpretation, and inversion. We completed up to the interpretation in phase 1. And then when we moved into phase 2, we finished off the inversion work on the initial data sets. We've been through 23 different geometries to date. Very exciting. And phase 2 was focused on going to the field. So one of the companies was planning a 4D seismic program, and we were able to bring in our EcoSeis project and acquire that there as well. But we also wanted to study other types of equipment. That's what the dispersed source and receiver arrays are. We did some environmental studies, and we're doing the emissions tracking. So here you can see just some very quick results. This was out of the desktop studies. We're looking at seismic section here, the red and the blue wiggles. And then the thing that's the triangle, that's a seismic gather. And we need that if we're going to understand rock properties. And then everything's been coded into our software, the OS design. So this was the desktop study where that data set has a 50% footprint reduction, and it had, I think it was 55% reduction in GHG emissions. Now, if you are interested in seeing more of the technical results, we did recently publish 2 articles, one in First Break, which is the EAGE's journal on the miniaturized equipment, and one in the Leading Edge, which is the SEG journal on EcoSeis. And it goes through all those phase 1 results. And you're welcome to contact me, and I can send you a link to check out the article. Phase 2 is what we're focused on right now. And I'm going to go through a couple parts of that. So we completed a 20-year regrowth study in 1 year. And the way we did that is some seismic lines had been cut 20 years ago and they hadn't been recut. So we had an environmental team go out and do sampling to look at various properties on and offline to see how different habitats recover. And then we're using that to guide our geometry planning with different geometries for different habitats. There is a line cutting study. It's like, could we modify how we cut these lines to help the regrowth in the more sensitive areas? So that is going to happen. And then we're in the middle of our emissions tracking study. This data set study, it says 20 plus decimations. They're now at 23 and counting. So if you have a geometry idea you've always wanted to test, we're curious, please contact us. We're very grateful to Synovus for the data set to work on that. And that's what some of those publications are based on. And I forgot to mention PTAC, they're the main sponsors of the environmental work. And then we did just acquire a data set in the field with Conoco, and this was the 4D and the overlapping EcoSeis program that was acquired October to December of this past year. And we are now in the midst of processing that data, and then we'll be moving on to the interpretation and inversion. And results are looking very good. We're very, very happy with how that's coming along. So these were all the successes of the project, but there were some, and then this is of course all going into the software. There were some changes to the plan and some lessons learned. So I'm going to start with kind of the technical changes to the plan. Originally, we wanted to do everything in one location. So we're very optimistic when it comes to contracting, equipment availability, how many people we can actually put in the field in a limited time frame. But the reality is that we have a very short time frame in winter to be able to get out there and acquire the data. And if equipment isn't ready at the right time to all go forward, we didn't want to slow down Conoco's 4D. So we ended up dividing up the test into a few different locations. So we did kind of the main 3D study at the Conoco site, and then we went to Synovus and we acquired a dispersed receiver array. And for the geoscientists, really exciting, 8 different geophones. We're looking at broadband frequency content, focusing on the lows and the highs. This will be a really exciting study. And the companies that participated in this, they had seen some initial presentations we'd done last year, and they really liked what we were doing to fully analyze the technology all the way through to the end rock properties. So we had equipment manufacturers come to us and say, we would like our equipment tested. And they were able to come in and bring that equipment. So I would encourage you to always look for opportunities to collaborate. There are some other manufacturers that we're hoping to do more testing with because due to the timing, we couldn't do everything right at that one spot. And then the same thing happened on the miniaturized sources. We wanted to do this dispersed array because, again, we're looking at how can we get a lower footprint but still get that really good data quality. And Canadian Natural offered up one of their sites where we went and ran that test, and it's currently in processing as well. And we're hoping to do some more testing on that to incorporate everything together this fall. So some of the technical changes, I am just going to talk a little bit about other challenges of the project. Glenn alluded to some with, figuring out how we get our reimbursements. As innovators, sometimes we look at all the different funding agencies and we think they're the same, but some of them are a reimbursement model. Some of them, like Alberta Innovates, will provide a large portion of the funding up front. And when you're a small company, looking at how that cash flow progresses through a project is extremely important. So we're extremely grateful to our 5 oil company participants who were able to step forward and help when there were, let's say, hiccups in some of the reimbursement process, and things are now progressing much smoother. That speaks to another challenge, and that's contracting. I mentioned that we have 34 companies working on the project. We're developing IP. It's important to protect your IP. IRAP has been fantastic in actually putting us into an IP assist program to help us better understand the different types of IP and how to protect that. And then contracting. You're going to need to make friends with your lawyers. If you want to do this right, it's very important that the contracts match. So one of the things we had to ensure was that the clauses in our contracts with the oil companies were similar to the clauses with the contract with CRIN and then with all our subcontractors. And that does take time and effort, but it's an important part of the process. So moving on to collaboration. I mentioned the 5 companies that are sponsoring the project: Canadian Natural, Cenovus, Conoco, Imperial, and Suncor. Without them, the project wouldn't go forward. On the contracting side and challenges, we have one contract that everybody signed. And as a small company, you might be wanting to make business decisions very quickly. It took 6 months to sign the first contract, and to us, that was forever. And they told us, well, it normally takes 18 months. So something to keep in mind when you're working with large corporations is that there is processes to go through, and having a good legal counsel as a small company can help with that significantly. Because as an innovator, legal language and contract language is different from technical communication. At the bottom here, I've listed off all of our other funders. So COSIA represents these companies. They're all part of it. Same with Pathways Alliance. And they've also been amazing sponsors for us as we've gone out and done more public presentations. And then Alberta Innovates, CRIN, NRC IRAP, and PTAC. And then we have here, these were our field contractors. So they helped acquire the data this past fall, and this was new for them because some of the techniques we're using are different. So, they all had to sign NDAs, that's part of the contracting, and then work closely with them to figure out how do we make this the most efficient? What can we learn from them? What sort of feedback can they give to us to help us improve the process? So it's been a very collaborative approach. These are the equipment companies, so the equipment and the source technologies, and they've been wonderful as well. So they're all getting their own individual benefits of their specific technologies validated, because we need to ensure that it's going to deliver for what we need. And this leads to lots of papers, which is great for all of us and all these smaller businesses. And then we have our environmental group, and we've learned a lot working with the different environmental groups who've helped us do the studies in the field, do the emissions tracking, and really learn about the ecological side of seismic. As well, the oil companies have also provided access to their environmental groups, as has PTAC and Alberta Innovates. And then there are the other technology companies. So we have processing companies, interpretation software companies, companies that provide inversion. So these are all the contractors that we work with to help analyze the data. And again, this comes back to publications. You know, they're small companies. We're working with them to help promote them as well as ourselves and publish papers together. And then there's the universities. So the data we are acquiring is part of a data sharing agreement, and we are working with our sponsors, the oil companies, as well as the universities to get some of this data into hands of students to do further research, as there's only so much that we can do in the time frame of our project, but there's lots of new ideas coming out of all this work that we can then work with students going forward to further develop new technologies. So collaboration is incredibly important to us, and I encourage you to always be thinking about that every time you're talking to another company. So the next steps, the technology, we're working in oil and gas right now, obviously oil sands, but it is equally applicable to mining. So critical minerals like, you know, tracking lithium brines, or traditional mining like for copper or gold. And then clean tech. So the technology is directly applicable to carbon capture and storage. We need seismic for that. We need seismic to plan geothermal wells. We need seismic for wind farm placement. There's all sorts of different clean tech applications, you know, other critical minerals like helium, nuclear waste storage. Anywhere where you need to see the subsurface, we can take this and help reduce the environmental impact, emissions, and costs of acquiring that image. So we are very excited about the potential to go out to CMC's facility and do some more testing with some of the equipment. So some of the different geophones, sensors, sources, and as well as our geometries, because we want to start testing in for carbon capture and storage. We just attended the Williston Basin Conference, interested in Aquastor. So there's lots of opportunities to collaborate with companies that are doing CCS projects. Geothermal as well. We've been talking with some of the universities in that space. So we are looking for pilots in other regions. We would like to test this, you know, not just in areas where we cut trees, but areas where it's open, and look at more efficient methods of moving the equipment around the field to reduce costs. And then we're looking for ways to leverage funding through joint research and development projects, as when we go through our technology development and we're in the field, we can reduce costs if we're working with other companies that also need to be in the field, so we can share on mobilization or deployment. So that is kind of the sum of everything I wanted to tell you, but I'm going to finish off with a thank you, not to just all the collaborators here, but also some of the supporting partners. So when we started our project, COSIA introduced us to Foresight, and we began working with them, going through some of their launch and deliver programs and working with their executives and residents. This has been very helpful, and we were recognized this past November as one of the top 50 most investable companies by Foresight. And then I want to say a huge thanks to Pathways and to PTAC for sponsoring us to attend Sarah Week. I wasn't really sure how that would be applicable to us as a technology company, but they encouraged us to apply to the HEDI, which is the Houston Energy Transition Initiative pitch competition, and we won a spot to pitch. And that was fantastic. I thought that was good enough. We won our pitch category. And that was just like absolutely amazing. So there's no money directly involved with that. That would be great if there was, but it came with coaching. So we won some coaching with Halliburton Labs, as well as introductions to investors and meetings with them. And it's really starting to open up opportunities in the US and international. And we also, there's a picture of us there with Unique Ventures. Foresight introduced us to Unique Ventures, which is a Houston-based accelerator. And they were some some of the ones that helped us with initially learning how to pitch, because as a technology company, that's something you're probably going to have to learn. So again, I just want to say thank you to CRIN, thank you to all of our collaborators, and thank you to the team at OptiSeis, because they have worked very hard to get to this point.
Awesome. That was amazing. Thank you so much for sharing that with us, Andrea. I am just so inspired after hearing all that. So thank you. Okay, so our next one is another project that I've been very excited about too. I think when people think the land theme, they think, oh, it's all just surface and trees and plants. No, it's subsurface too. So we are novel land and well site reclamation. And so this is a project too that I'm really excited that showcases some of the subsurface element too that is part of our theme. So I'll invite Fred to come up here. Fred's the manager of the in situ recovery team at InnoTech. His research team, you guys focus on a lot of different things. As I was reading through it, I was pretty impressed. So some of the things include traditional chemical flooding methods to help improve heavy oil recoveries, developing then the concepts from kind of bench to evaluation on those. You guys are doing stuff with effective thermal solvents that help with recovering kind of bitumen and lowering the GHG footprint. And then this project here is something maybe a little bit different where you're looking at cement alternatives as well. And so something that I'll let you speak on too. And so your chance here with these questions.
Okay.
It's going to be fun. Favorite day of the week?
Friday afternoon.
Oh, good time. Good time. What place would you like to travel most to?
Costa Rica.
That sounds wonderful right about now. Favorite thing about Canada?
Opportunity.
Awesome. What could you eat for an entire week straight?
Hungarian goulash.
Okay. And then Starbucks or Timmy's?
Timmy's. Can't
Awesome.
afford Starbucks. No research salary.
Awesome. Well, with that, I'll let you take it away.
Okay. Hey, thanks for this opportunity to present this project on testing alternate products in place of cement for well remediation and decommissioning of wells. We have a fantastic collaboration going on here. I'll get into that a little later, but I would like to highlight one of the people that was instrumental in getting this going. And it's the fellow is Jerry Boyer. He wants to be retired. He's a legend in the industry, but we keep clawing his time back towards expert consulting in this well integrity area. Okay, let's see. Okay, let me define the problem overall that we're facing. Within Canada, we estimate there are about 54,000 leaky wells that need remediation. And in addition, they're on the order of 250,000 wells that need to be abandoned in the next decade or so. That's a giant number of wells that we need to address, and we cannot sidestep this problem. We need to work with the operators in order to solve the numbers that we're dealing with here. Currently, cement is used as the main well remediation or closure technology. However, cement plugs and cement remediation applications are inadequate. Usually it takes on order of on average, three attempts in order to remediate a well. And we also think that the well plugs that we are placing will eventually leak, or a certain degree of them will leak. So we need better technologies that are alternatives to cement. They should be more robust, longer lasting. And when it comes to sealing leaky wells, you should use fewer intervention in order to get there. So that's essentially the problem definition of, and we went about looking at alternative barrier materials, and what we're thinking of would make excellent material barriers would be a more liquid composition rather than cement. Cement is granular. It has a tough time squeezing into tight places. Something that's stronger than cement, more chemically resistant or corrosion is resistant over time, has a low permeability to fluid flow, and then ideally is very easily deployed, especially if you have a rigless deployment and just send it down on a wire line. So those would be the ideal candidates for applications. However, most products that we're dealing with, they fill some of these categories, but not all of them. So there's no silver bullet for the industry. However, it does show that we should have a toolkit of these technologies available. And so we started talking to some of the industry experts with regards to this problem. And it's not only Canada that faces this problem. This is an international problem. Like we started talking to people in the UK who are dealing with North Sea or offshore applications. We've been talking to people in Australia. They've also have a large number of wells to deal with. And then the US. The US has the largest number of wells that need to be abandoned. So this is an international problem. We were able to gain some interest several years ago, especially PTAC was involved with in the beginning when we brought this concept of testing alternative technologies, and they were very receptive, especially with the WARI group that they're organizing. That's a well integrity group, which consists of most of the operators in Calgary. And they were also in favor of testing alternative materials for such applications. So PTAC was involved with right at the beginning. And then by chance, we had a fellow visit from Aberdeen, Scotland. He was involved with the Net Zero Technology Center. He was also an engineer with Spirit Energy. And we managed to get talking to him about CO2 storage, but then his main idea or main issue was trying new well remediation technologies in the North Sea. And the offshore operators love coming to Alberta because trying a technology onshore is an order of magnitude less expensive than trying things offshore. So the simple economics are we can do 10 field trials onshore in comparison to 1 field trial offshore. We managed to get the Net Zero Technology Center in the UK interested, and they started to gather some funds through a consortium that they're running and bring it over to Canada for field applications. In the end, we managed, with CRIN funding, we managed to bring together a project on the order of $4 million, where, okay, with CRIN funding, you need to have eligible budget and ineligible. So the eligible budget towards the testing and so on of the products is on the order of $3 million. The reason the overall budget goes to $4 million is because the operators are contributing well excess in kind. So that is the other $1 million on the budget here. The operators that are working with us are listed down below. Cenovus, Medicine Hat, Canadian Natural, Crescent Point, ConocoPhillips, and actually the last one, it's Suncor, Westlake. I need to modify the slide. That's an oversight on my part. And at the moment, we're open to even further collaborations. If operators or technology developers want to bring in additional technologies to look at, then we're open to that. So the overall project objective is to test and field trial alternative materials. Initially, we selected in this program, we selected 5 innovative products. That selection was mainly based on the operator's preferences. We ran an infomercials for these different service providers so that they could showcase their technologies through a webinar series that we held. And then based on that, the operator selected the 5 products that they would like to test in the field. So then that was the first component of this project. The second one was actually doing the testing. InnoTech has lab facilities, and we are essentially an independent evaluator. We have no skin in the game. We do the testing, and based on the independent testing that we do, we write recommendations. We do not sell products. We do not work under contract. We could work for operators, but we are not in this particular case. We're completely independent of anybody. So once the testing is complete, recommendations will be made, and if the products pass our testing protocol, we go to field trial. And so within this project budget, there is 2/3 of the budget is set aside to field trialing. And according to initial estimates on my part, we have enough money in the budget to do 3 field trials per product. And in the end, once all the information is in, we are set up to do data sharing with all the field trial results. And this is where PTAC comes in. They have a fantastic network of bringing the data out to the operators in Calgary or international. And also the NZTC can disseminate the information to their North Sea operators. Okay, so when it comes to alternative materials, we have on the order of 50 different, or it's probably closer to 60 different service providers that provide products to the, or tout that they have products that they would like to use for well remediation and closure. And if you look at the list, that's an incomplete list. So we've added on to it. But you can generically group these things into metal alloys and activated resins and polymers and so on. And I'll just highlight the 5 product areas that we're doing within the current project. So the first one, as I mentioned, was metal alloys. The other one that we wanted to look at is temperature activated resins. So that's essentially very similar to the resins that you can buy at Home Depot. That's a similar type of application. Ceramics, we had one ceramic product that would go in as a slurry and then form a nice sealing product underground. However, the company had some IP issues, so our contracts administrators said, don't touch them until they've worked that out. So we're looking at polymer combinations or nanopolymers that set up as like gel-like. What else do we have? We have in situ precipitates like calcium carbonate and calcium sulfide, which is gypsum. And then we are also adding some enabling technologies, which need to be there in order to apply these plugging and sealing materials underground. Okay, so as I mentioned, InnoTech has some laboratory capabilities. We're actually owned by the provincial government, been around for 100 years, 1922, so it's 101 years. And one of our claims to fame, Carl Clark in 1925, early on, developed a steam process to separate bitumen from the oil sands. So we haven't done much since then. Okay, so I have a fun playground where I have physical equipment for us to do toxicology assessment. We can do pressure testing of the products. We do endurance testing where we rock the product back and forth in a caustic brine for 6 months and see the deterioration of the material. And in addition, we do shear adhesion testing where we use a cylinder and try to force the product out of a casing to see how it adheres to the casing wall. And I must say, this is our phase 1 testing. Within this phase 1 testing, we get surprises, and the service company that sent their materials get surprises too, because usually they have not tested their materials to the same rigors that we test them to. And so then, depending on how close or bad the materials fail, we can either work with them and provide some suggestions of how to improve, or we say, hey, you better go back to the drawing board. So, so then on the second phase of the testing, we look how the product seals in cement wormholes and fissures. We squeeze the product through very tiny fissures, less than 100 microns. Actually, in some cases, we squeeze the material into a sand pack where the smallest pathways are on the order of 15 microns. So about the size of a hair that it needs to squeeze through. And then in the far-reaching test is we generate a gap 1/8 of an inch. That's on the order of 3,000 microns. So we see under which condition the product works, and more importantly, under which conditions the product fails, and we make our recommendations based on that. In addition, working with the operators, they're saying, hey, when we place our product, there's usually gas whistling by if we have a leak to fix, right? So this material needs to also work when we have an excessive gas pressure that's trying to channel while you're placing your sealant, that's trying to channel through the sealant. So this test, this gas invasion test, we didn't have until we started the project. And that was actually through operator recommendation. So we're taking feedback from the operators of what their real problems are and trying to test it on our products. Okay, let's get to some of the products that we have been testing. I'll be a little cryptic with the results because these results have not been presented to the operators yet. The testing program is going on. So I'm trying to be a little cagey here because I didn't get operator approval yet to show these results. But this one here was the first product that we tested. This was before the CRIN project started. It was a resin product, and in order to change the density, they had mixed in some bentonite. And the enabling technology that they used was a dump baler. So what this product showed, it had tremendous strength, chemical resistance, set up barriers that were of low permeability, so there was no flow through them, so it had no permeability, and it was a rigless deployment. Actually, their dump baler technology was interesting. They essentially set up a bottle with the product inside the bottle. They sent the bottle down the well bore. It hit the packer that they had set up inside the well. So essentially they dropped a little bomb, but you should know that the well bore is usually filled with water, right? It's not like you're sending it down that the well bore is filled with gas. So there's some buoyancy holding it back. The bottle breaks on contact with the plug, with the temporary plug that's set at the bottom where you want to place the permanent plug. It breaks, dumps the product out, and it sets up as your formulation predicts. So the enabling technology here with their product, even though the product was more costly, reduced the overall cost of application by 30%. So this was one of the first products that we tested. The second product that we're testing now is a metal alloy. It's a molten bismuth alloy. all the test results aren't in yet, so I didn't put the technology provider on here. The idea is you send metal ingots down into your wellbore, you generate heat, and there are two ways that operators or service companies are generating the heat. One is with electric heaters. The other one is using a chemical reaction like thermite, which is people on the railroad use it in order to weld railway ties together. So it can generate a lot of heat. You melt your ingots in place. If you heat the surrounding hot enough, temperatures needs to reach above 125, 130 degrees. And then if you have a temporary plug set up, your ingots will melt in place and provide a permanent barrier. So once the bismuth alloy is melted, it reaches a viscosity of around 2 or 3 centipoise. Water is 1 centipoise. It has a tremendous strength when setting. It'll nearly last forever. So there are not very many chemical reactions that will attack it. The barrier is impermeable. And in the one case, if you use thermite, it's rigless deployment. You just send it down on a wire line. If you use the electric heater, it's still a rigless deployment, except then you need to have a cord along that supplies the current for your electric heaters. So this product, we also already have had 2 field trials in that are being evaluated right now to see how well those plugs set. And yeah, we just have to wait till the field trial results are in. The next area that we're working in is nano sealants. There are 2 service providers that are providing different nano sealants that set up very much gel-like. One is a biopolymer that we're using that has a where you add a cross-linker in order to set it up a gel, very much like the Jell-O that you have at home. Again, here for the nano sealants, the viscosity is very much like water. It's non-granular, can easily be applied. The strength is not the same as your molten alloy. It's more like the Jell-O at home. However, so it has some chemical resistivity. It can provide an impermeable barrier as long as the fissures that you squeeze it in are small enough, because then the rock and the substrate support your sealant. Once your diameter goes beyond, let's say, 100 microns, the material no longer gets supported by the walls, and it can be extruded. So then your barrier fails. So you can see down here, we set up cement slabs, and we space them with little shims, 100 micron shims, 200 micron shims, all the way to 3,000 micron shims. 3,000 microns, you can actually see a nice gap. 3,000 micron is 1/8 of an inch, so you can look through the gap. But with 100 microns, that's the size of a hair. You cannot look through the gap. And excuse me. We're having good success with the placement of it. Our recommendations are, though, you need to know what your leakage pathways are, because if you use it in the wrong situation, it'll extrude. And then the last technology that I'll talk about that we're testing is in situ precipitates. One company is providing a calcium carbonate technology, and another company, which is quite exciting, they have a biomineralization process where you have microbes in the solution in order to initiate your crystallization. And so these products can also be used in very tiny pathways. or they can be injected directly into the source formation where your leaking fluid or gas is coming from. And the last two products that I talked about still need to be field trialed. Okay, so those are the technical aspects of the project, and it was requested to talk about the risks and challenges that we're facing. So, as I mentioned initially, in order to find the best products, we ran webinars. We looked at what the support we could get from the operators in order to test these products. And we found that the operators were quite willing to support testing these products as long as they knew about them. And so the webinar series and the support from the operators went hand in hand. The sharing of the information, we are well set up, especially through the webinar series. We already have an open audience that's willing to listen to us. Now, we did find the same issues where we didn't really think we have that big of an issue, and that was with contracts. My first contract administrator said, can't deal with the 6 operators, the federal government, the provincial government. So she literally threw up her hands, we need somebody else. So then we did find the contract administrators that would tackle the problem. And we did not get it done in 6 months. It took us a year. And I would love to talk to you about how you managed to do it in 6 months, but yeah, it literally a year to get the contracts in front of the operators. And the government entities were easier than the operators. The operators were more concerned about their IP and then the IP of the new technology. That I did not expect. That was a new one. I thought we'd have more technical problems, which we do have technical problems, but I can manage those ones a lot easier. Oh, the other issue that we had, getting foreign money in, do you charge GST or do you not charge GST to that? So we have not solved that one yet. Okay. Oh, and then we do see the public benefits developing these technologies in Alberta, testing them here, even though we have foreign companies, service providers bringing their products here. We are developing a lot of know-how and how to apply them, plus enabling technologies. And I should mention there are two enabling, the one enabling technology with the bale dumper that breaks on impact. That's one thing that's being developed. The other ones are cutting access through the pipe in order to get at the rock. And another technology that's being developed up in Red Deer. And I'm missing a third one. Oh, using applicators where you do the mixing right at the plug, so that some of these chemical reactions happen quite quickly, and so you want to get the timing. I'm wrecking the place. You want to get the timing just right. So in addition to just the products itself, there are other things that make it work. And so we think we have an excellent chance of creating a lot of full-time jobs. My team did not double or triple in size. We hired 2 extra people though, which is significant on the research side. We're on the cost tracking. If you apply these technologies to the 50,000 wells that are leaking, that cost tracking is on par. Cost reductions, CO2 reduction, protect groundwater. And then the restored sites from closing the wells and making the sites habitable again, or return them to previous use is huge, as you can see. Okay, and then in summary, I think this is a fantastic collaboration, both locally and internationally, with government sources and local industry support and their in-kind contribution. This project brings a smile to my face every day I work on it. So thank you.
Awesome. Thank you very much. That was great, Fred. I really appreciated that. So we'll ask Fred to come up. We'll ask Andrea to come up and we'll start some Q&A here. While we're just getting ourselves set up for this, I just wanted to acknowledge that Canadian Natural did provide the goodies this morning. So there's still a lot here. If you're here in person, please help yourself or take one on the road for a friend when you leave. But while we get set up here, oh, thank you so much. I'll maybe just start with a quick question for the two of you. You have a seat and I'll grab one more microphone here. But if we want to learn more about both of your projects, what's the best way to follow you? So maybe I'll start with yourself.
Oh, just contact us on our website, InnoTech Alberta, and you'll follow the tree and get to me, or I'll put the contact information on today's presentation.
Perfect. And Andrea, yourself?
You can go on our website, our LinkedIn, or email info@optiseis.com, or even myself directly. I think I'd put that on the bottom of the presentation.
Awesome. Thank you. And then one other question that I'll start with here too is, obviously you guys both spoke to the collaborative nature of your projects. And I just find that so inspiring. I think that's what really kind of, we want to showcase at CRIN. We want more of that. We want to see that collaboration. How active or passive were you with that? Was it something that you actively were driving? Was it something that just kind of naturally happened? What was your experience there?
I think you have to be quite active. And I think if you have an attitude of curiosity, like what is somebody else doing and how could you help them, you'll start to see opportunities everywhere.
Awesome. Thank you. And how about yourself, Fred?
We had some great initial collaborations with PTAC, and they have a great outreach program to different operators and technology developers. And then the serendipitous event of coming across a guy from the UK that said, hey, whatever you're working on could work over there. So that was a benefit.
Awesome. Do we have any questions in the audience or online?
Can I make a comment here for Fred? And that's about the contracts. So we are a bit lucky in that our project was sponsored through COSIA, and the 5 companies already had an agreement with each other. So we didn't have to negotiate individual agreements to get them to share. It was more them with their COSIA agreement working with us, and then ensuring that we utilize that going forward.
Okay, that makes me feel better because we started at ground zero, and like in the end I said, just give in, like get those contracts out there. I haven't had a bad contract in the 20 years that I've been working here, so let's get on with it. So yeah.
Awesome. We have one question here in the audience. So maybe just like to introduce yourself.
Sure. Can I sit or should I stand?
You can sit.
Okay, great. Hi, everyone. My name is Adele Zenade. I work for Canadian Natural, and I'm also the chair of the CRIN Water Team. Thank you, Fred and Andrea, for your lovely presentations today. I found them very insightful. It's amazing to read about your work, but it's a completely different story to hear it from the people doing the work themselves. And so thank you for sharing your passion. It really shows. My question is for you, Andrea. So I'm just curious, if you could go back in time to the beginning of your OptiSeis journey, what would you tell yourself?
That it's going to work. It's research, so it's ideas, and you don't necessarily know like you think it'll work, but you don't really know. I would say too, to be ready to adapt and change plans as you move forward, because you're going to encounter surprises, unexpected results, and you'll also encounter new opportunities and new directions to go in.
Awesome. Thank you. We have another question too.
Is it on? Yes, it is. It's Ian Job. Hi, guys. Good to see you again. Question for Fred. So you've looked at a lot of different materials and different types, looking at your 5 parameters for success. I don't think you're looking, tell me if you're looking for one cookie cutter approach, or is there going to be part of the implementation too, is like you say, to understand the application and therefore the solution to fit the application. Are you looking at a portfolio of solutions here?
Yeah, we're looking for a toolbox
Yeah.
of solutions. And the beauty on this one, everybody can get into it, right? Like, so you have a good idea. We're willing to listen. We now have some pretty rigorous tests, and we're willing to put your technology through the ringer. So 2 examples. One, I talked to my neighbor on that, and he said, "Oh, you should just melt hockey pucks and put that down the wellbore." Problem with hockey pucks, unlike bismuth, hockey or plastic shrinks upon setting. So you can have a nice molten pie in there. However, once it cools, it'll shrink. Bismuth is like water. It'll expand on setting. The other part is we're quite flexible. There's the biomineralization companies out of Butte, Montana. And he said, well, we have our bioreactors down here, and we don't want to bring our big truck up into your lot because we're out in the field. We don't want to have. I said, well, okay, we'll pack up our testing equipment and go across the border. Butte is what, 6 hours away or something like that. So we'll go down there and do the testing there.
No, that's great. I mean, I think also a big piece of these types of projects is that prototyping, appropriately scaled testing it's applicable for field. So when you get to the field, no real surprises. That appropriate scale up, right?
So I must say the operators before this must have been at a loss, right? Because the service companies, especially during hard times, and believe me, the last 8-9 years were very hard, would rely on what the service companies were telling them without an independent evaluation. And we're actually finding that now with almost every product that comes in, it does not perform the same way that the service company touts it does.
I have a comment on that because I think it's similar, is that companies are now seeing how we go through the testing process, and they're interested in having their technology go through that as our operators, because not everyone has the time to do that. And now that we have a process in place, it works quite well.
Awesome. Thank you. I see another question here.
Albert Lee with Closure Liability Management. So as a company that actually executes wellbore abandonments, how shareable are your findings? And
So at the moment, because we have the 6 operators sitting at the front of the table, they'll get the results first. And because they've been patient, they've been supportive, they're making their wells accessible. So, but then at the end, because it's a CRIN agreement, the results will need to be shared. So we'll make the results available. Maybe not to the same degree that the operators get, but yeah, that's the agreement.
It's for the online.
Oh, sorry. Hi, online. Kevin McClanahan, On-Site Remediation Solutions. You seem to be focused on the wellbore itself.
Subsurface.
Well, but the wellbore itself, are you, one of your first graphs was the annulus where the methane is leaking between the formation and the cement bond.
Yes.
You're not really addressing that with
Yes,
this?
we
or?
are, because the cement plugs that where we are controlling the gap between the cement slabs, that's exactly what where usually the leakage pathways are on the cement side. So we're addressing exactly that issue, looking at different size leakage pathways and seeing what the limitations of the sealing materials are.
I'm having a tough time understanding how you can melt on top of a bridge plug or a packer and get that into through the pipe to get into that.
Oh, so that's where the enabling technology comes in. If you have a leakage pathway that you want to intercept, you need an enabling technology like a erosion tool or a cutting tool. And the operators have agreed to only use, in order to reduce the number of variables, to only use 2 enabling technologies in order to reach behind the pipe.
Just checking, is there any questions online? No, okay, perfect.
Hi, Bob Schultz, Haskins School of Business. The question I have is for both of you. One, what are you looking for that's going to move you to the next level? 2, what are your business models? And 3, how are you going to scale? Because that's what I would like to help you with.
Okay. So our business model, well, okay. So our business model is we have both software and we also have services. So for large corporations who have lots of people, they're more likely to take on the software. Whereas for very small companies, they may not even have the people with the knowledge to run software. So they're looking for services. So there's the 2 sides of that. But we're looking at some simpler software tools that we can get on every geoscientist or even engineer's desktop to make quick decisions. How we scale, well, software is scalable. Services are scalable to some extent as well. We bought another company last November. So we've been increasing that way. And we're also looking at joint partnerships in some areas. And then what we're looking for, 2 things. So we do want to run tests on a carbon capture site where we can get results that we can share for deeper targets. Same with geothermal and investment.
Okay, so one of the issues that you have is you're in rural areas predominantly. And one of the problems you have is moving data from rural areas to some place where they can do artificial intelligence. So if that's an issue, I know where that technology is, but also, and you have aspirations for scaling globally?
Oh, we already work internationally. And there's interest in this in South America and Australia and the US.
Right.
So for me, it's slightly different. Our lab is owned by the provincial government. So we do independent testing, but we get paid for those services. We charge an industrial rate. As far as the products that we're testing, there are 2 things. A, they need to pass our testing protocols, and then we will advertise or suggest or recommend to the Alberta Energy Regulator that this product can be accepted for well remediation or closure under given conditions. In addition, the tests will be first made available to the 6 operators that are at the table, and they can choose based on the results whether to apply those technologies or not. So that's an advertisement for that service operator or product. And then beyond that, the results will be made available through the CRIN network or PTAC. So if the results are from our tests and from the field trials are positive, that in itself then is an advertisement globally, essentially. So, yeah.
Awesome.
Yes.
We have time for one last question, and I see it. So
What Fred said, I think part of also that acceptance is when the AER moves to putting it into their direct.
Exactly. Correct.
awesome. Any other one last question here? Anything online? Triple checking. Perfect. Well, thank you very much, both of you. I really, really appreciated your time this morning. You guys sharing kind of the passion, like Adele said, the passion behind these projects. It's really exciting to see. And yeah, wish you all the best as you guys continue, and we'll be avidly following you and cheering you guys on. So thank you. Perfect.